Hey everybody, today we're going to look at Charles's law, which relates volume and temperature. Now, previous to this, we've looked at Boyle's law, which related pressure and volume. Now we're going to talk about how volume and temperature are related. So one thing that you should have already learned is that, let me zoom in here for a little bit, is that as the temperature increases of a gas, then that in return leads to an increase in volume. So as temperature increases, volume also increases. So if you take a look at the diagram here on the left, you've got a gas that has a specific volume. It looks very compressed. All these gas molecules are very close together, and now they're above a heat source. So this flame here is going to heat up this gas right here, and over time these gas molecules start to spread out a lot more. So because they're spreading out a lot more, they're taking up more space, their volume has increased, and you'll notice that their temperature has increased as well. So as a result of an increase in temperature, placing this gas over an open flame, this volume has increased as well, and we would call that a direct relationship. So, in other words, as volume increases, as temperature increases of a substance, the volume of that substance increases as well. And a direct relationship means not only is there going to be an increase, but in other words, if whatever the temperature does, the volume does the same thing. Okay, so if I reverse this process, and let's say this was my starting temperature and my starting volume, if I cooled down this gas, if I turned down the heat and allowed the gas to cool down, the temperature to drop a little bit, then my volume would also decrease. So whatever your temperature does, whether it increase or decrease, your volume of that gas is going to do the same exact thing. So another example, and maybe some of y'all have seen this before, but if I inflate a balloon and tie it, there's a certain amount of gas in that balloon. If I put that balloon that has some gas in it into a bath of ice water, that balloon's going to start to compress a little bit because the temperature has dropped and the volume has dropped as well. But if I take that same balloon, I don't add any more gas to it, I just take that same balloon and move it from an ice water bath to boiling water, that balloon's gases are going to start to expand a little bit more. They're going to start moving around more rapidly. They're going to take up a lot more space. The volume is increasing due to an increase in temperature. And I'll see if I can show you a video related to that in this unit. So Charles' law, it's expressing a relationship between volume and temperature. Okay, so how does that look mathematically? Let me zoom in here. So here's Charles' law. Charles' law says V1 over T1 equals V2 over T2. So remember that capital V measures volume and capital T measures temperature. Okay, so I've got volume and temperature. So the ones and the twos, the one is referring to the initial temperature or volume, or what it started at. So this is the starting or the original volume and temperature. And the twos are referring to the new volume or new temperature. Okay, so just keep that in mind. The ones will be together, the twos will be together because you're comparing the starting volume and temperature to the new volume and temperature, and we can set up a relationship or proportion based off of that, and I'll show you how to do that. All right, so one of the things that we mentioned previously is that anytime that you're measuring the temperature of a gas, these gases must be measured in kelvins. Okay, so when we're using these formulas and we are trying to calculate temperature, these temperatures must be in kelvins, always. So remember that Kelvin is equal to your temperature in degrees Celsius plus 273. So let's say I've got a temperature of, I don't know, 20. So let's say my temperature in degrees Celsius is 20 degrees, and you need to convert it to kelvins. All you have to do, based off of this equation, is add 273 to it. So 20 degrees plus 273 Kelvin gives you 293. So that temperature that was once in degrees Celsius is now in degrees Kelvin. Okay, so let's take a look at some examples. We'll look at example 1 first. It says a gas at STP, and remember that STP stands for standard temperature and pressure. So let me write that up here. Standard temp and pressure. Okay. We'll come back to that. It has a volume of 250 liters. I want to calculate its new volume if the temperature increases to 30 degrees Celsius. So let's look at what we've got here. I've got a volume of 250 liters. So this is the initial volume, it's the starting volume, so I'm going to label that V1. I want to calculate the new volume. So it's telling you that you need to calculate V2. So V2 is unknown. It says the temperature is increasing to 30 degrees Celsius. So this is telling you it is increasing, which means this is the new temperature. So that has to be T2. So what I need to figure out is, what is T1? T1's not given to me here. But remember, STP means standard temperature and pressure. So what is standard temperature? Well, standard temperature, if I'm looking at degrees Celsius here, then my standard temperature would be also in degrees Celsius. And standard temperature in degrees Celsius is 0 degrees Celsius. So that is my standard temperature. So that gives me my initial temperature, my initial volume, my initial temperature, initial volume. My new volume is what I'm trying to solve for, V2. And my new temperature is given to me, it's 30 degrees Celsius. So I'm going to list over here on the left the variables that I have. So V1 is 2.5 liters. T1 is 0 degrees Celsius. V2 is the volume that I need to solve for. And T2 is 30 degrees Celsius. All right, so one of the things I mentioned is that temperature needs to be measured in Kelvin. So if Kelvin is measured by taking your temperature in Celsius and adding 273, then I'm simply going to add 273 to this temperature. And 0 plus 273 gives me 273 Kelvin. And I'm going to add 273 to this temperature. And 273 plus 30 gives me 303 Kelvin. So now I've got my temperatures converted to Kelvin. My volume is ready to go. Now I can substitute into my equation. So my equation says V1 over T1 equals V2 over T2. So I'm going to plug in the information I know. V1, my starting volume, is 2.5 liters. My initial temperature converted in kelvins is 273 kelvins. Equals V2 is what I'm trying to solve for. I'm trying to figure out what my new volume is. And T2, after converting it to Kelvin, is 303. All right, so I've got my proportions set up. Now, because I've got a fraction on the left, a fraction on the right, I can simply cross multiply. So I'm going to cross multiply V2 times 273, which is just 273 times V2, equals, and I'm going to cross multiply 303 times 2.5. So 303 times 2.5. Alright, so we'll combine terms on the right. 303 times 2.5 gives me 757.5. And 273 times V2 is still 273 times V2. So the next step is to get V2 by itself by dividing 273 to the other side. So V2 is equal to 757.5 divided by 273. And once you calculate 757.5 divided by 273, you should get a new volume of 2.77 liters as your answer. Now, one of the things I want to mention is you can get a better understanding or an idea of what this new volume will be if you can remember the relationship between temperature and volume. So we said that temperature and volume have a direct relationship. So whatever your temperature does, your volume does the same thing. So in other words, if my temperature starts off at 0 and it is increasing to 30, so in other words, my temperature is increasing. So an increase in temperature also leads to an increase in volume. So if my temperature is going up, my volume has to go up. If my initial volume is 2.5, then I know that this volume cannot be anything less than 2.5. It has to increase. And sure enough, it increases to 2.77 liters. All right, let's move on to the next one. Example number 2. And example number 2 says calculate the decrease in temperature when 2.00 liters at 20 degrees Celsius is cooled to 1 liter. Okay, so let's identify some of the things that we are given here. It says calculate the decrease in temperature when 2 liters at 20 degrees Celsius. So this is my starting volume. This is V1. 20 degrees Celsius is my starting temperature, so this is T1, and it's cooled to 1 liter, so that's telling me this is being cooled to a new volume. This is V2. So I must be asked to figure out the new temperature. So in this case, T2 is unknown. Okay, so I'm going to go ahead and write out some of the information that we have. I'm going to list V1, which is 2 liters. T1 is 20 degrees Celsius. V2 is 1 liter. And T2 is what we're trying to solve for. Okay? So remember that our temperature always needs to be in Kelvin. So to convert to Kelvin, you take your temperature in Celsius and add 273. So 20 degrees plus 273 gives me 293 as my temperature in Kelvin. Okay. Now, let's take a look at it. So my volume is going from 2 to 1. That's a decrease in volume. So my volume is decreasing. So remember, volume and temperature are directly related. So whatever your volume does, your temperature has to do the same. So that means my temperature has to decrease as well. If my temperature starts at 293, then this new temperature has to be something less than 293. So let's see if that's true. All right, so the equation says V1 over T1 equals V2 over T2. So now we substitute. For V1, I'm going to plug in 2 liters. For T1, my new temperature in Kelvin is 293, equals V2 is given to me, my new volume is 1 liter, and the new temperature is unknown. So T2, I'm going to leave it as T2. So now I've got a proportion on the left, proportion on the right, I'm going to cross multiply. So 2 times T2 is just 2 T2 equals, now let's cross multiply on the right, 293 times 1. So on the right I've got 293 times 1, which is simply just 293. And on the left I've still got 2 times T2. So now to get T2 by itself, I've got to divide 2 to the other side. So 293 divided by 2 gives me a new temperature of 146.5 kelvins. And sure enough, this temperature is less than the starting temperature. My starting temperature was 293, and when my volume decreased, my temperature decreased to 146.5. Alright, let's try one last example. Example 3 says a helium balloon in a closed car occupies a volume of 2.32 liters at 40 degrees Celsius. If the temperature inside the car reaches 75 degrees Celsius, determine the new volume of the balloon. Okay, so let's identify some of the information that's given to us. The balloon in the car occupies a volume of 2.32 liters. This is my starting volume. And that starting volume is at 40 degrees, so that's my starting temperature. If the temperature reaches 75 degrees Celsius, so this is my new temperature, determine the new volume. So I want to figure out what V2 is. Okay, so I'm going to write some of the information over here on the left, starting with V1 equaling 2.32 liters. T1 is 40 degrees Celsius. V2 is what I'm trying to solve for. And T2 is 75 degrees Celsius. Okay, so looking at this, my temperature starts at 40 and is increasing to 75. So an increase in temperature, based off Charles' law, leads to an increase in volume. So I know that if that is true, then my volume starting at 2.32 should increase. This number should be greater than 2.32. So let's see if that's true. So the equation, actually I almost forgot something. We need to convert our temperature to Kelvin. So to do that, I'm going to take my degrees Celsius and add 273. Alright, so T1 is 40 degrees plus 273 gives you 313 Kelvin. And T2 is 75 degrees plus 273 gives me 348 Kelvin. So now I've got my temperatures in Kelvin. Now I can proceed to my equation. So the equation is V1 over T1 equals V2 over T2, where V1 is 2.32, T1 in Kelvin is 313, equals V2 is the new volume that I'm trying to find, and T2 in Kelvin is 348. So now I've got my fraction on the left, my fraction on the right. I'm going to cross multiply. So 313 times V2 is 313 V2. And 348 times 2.32 will be on the right. And it doesn't matter which one you write first or which one you write second because you're multiplying. It makes no difference. So I'm going to combine like terms on the right. 2.32 times 348 gives me 807.36. And on the right, I still have 313 times V2. So to get V2 by itself, I'm going to divide 313 to the other side. So 807.36 divided by 313 gives me a new volume of 2.58 liters. So, like we said, if my temperature is increasing, then my volume has to also increase. If my starting volume was 2.32, my new volume is 2.58. That is an increase in volume. Therefore, Charles' law, showing the direct relationship between temperature and volume, is true. So use these notes, use these 3 examples to complete the classwork for this week.